Okay, so now we're on part 3 of our chapter 1 problem solving video set. This is geometry and applying those skills here. So page 13 of your workbook. Okay, so we have geometric shapes as well as area and volumes can be important in problem solving. We can use proportions to determine heights, length, width, area, volume, etc. of any object we wanted. So we just have to make sure that we're consistent with how we compare things. And when we're using proportion, you don't want to mix that with the method of dimensional analysis or unit analysis that we use when we have unit fractions. That's a different process. So just keep that in mind. So I'll try to clarify which one I'm using here. You can do things one way or another and pick your method that you like, but you just don't want to mix them up like as you're working in a problem and switch gears midway through. So we have our info for rectangles and circles here just as a review. We have this problem. We're going to look at example 1.13. If a 10-inch diameter pizza requires 12 ounces of dough, how much dough is needed for a 14-inch pizza? Now, any of these you can do as a classwork if you want to pause, if you think you have the idea how to do it and want to go for it and just check your answer, that is totally fine. I think many of you do that. However, this one I am going to do as an actual example here. One thing I want to point out, if you are doing it as a classwork, be careful because we do need to compare the proportion of the area. We don't really need to do volume. We're going to assume equal thickness. But you can't just compare diameter to diameter. You have to take into account the entire area. So I'm going to put a note here to start. So I just wrote your little note here reminding you that we are not given a thickness or height per se, so we're going to assume they're equal thickness, although that might not be true in the real world. But so we can take this volume of the dough and assume the height is 1. So we really can just use the area formula is what I'm going to do, kind of putting in 1 for the height. But if you had different thicknesses that were given, you would definitely want to use the volume formula. I'll actually even just compare it as volume, putting 1 in for the height. And we're going to have a couple of circles here. I'm going to draw out some diagrams so you can see what the pictures look like. A little rough cut probably. So I drew my beautiful pictures here of the, this is the 10-inch pizza, in case you can't tell what it is. And this is the 14-inch pizza. And I already figured out the radius here is 5 inches on the 10-inch pizza and 7 on the 14-inch. I'm going to figure out the area you could do, or I'll actually write it out as volume. Pi r squared times height, and my height on each is going to be 1. So for the 10-inch, my area or volume, just do it that way so it's consistent. Pi times 5 squared times 1. And that comes out to be approximately, because I'm going to use my pi key on my calculator, or I'm going to stretch out pi pretty far. So 3.14159, so that I don't get too much round off buildup. But you can generally round just a couple of places in a final answer, but not within a problem. So I would end up getting approximately 78.54 inches cubed. And then on the 14-inch, I'm going to get pi times 7 squared times 1. and that'll be approximately 153.94 cubic inches. So you can see where this is not necessarily the diameter. You can't just say, well, it's this times more in diameter, so it's overall that. It doesn't work out that way. We've seen that previously in some other types of things. I think in geometry you might have done something with that. So be careful with that. So for our proportion, we're going to set it up as ounces in the numerator, and then volume in the denominator. So we would have, we'll set up the 10-inch first, so that's 12 ounces over, I'm just going to round, and we usually don't round within problems, but I'm going to go ahead and round that off, 79 inches cubed, just to make the math a little bit easier for you. As long as we didn't round here too much, you know. Because if we put 3.14 in for pi all the time, that's going to start to give us a lot of buildup. So 154 inches cubed, x ounces, we don't know what that is. Probably should declare our variable too. We can write over here, let x equal number of ounces for 14-inch pizza. Okay, that's how much we're going to need. So then we can cross multiply. If you're ever not sure how to round, just ask. Sometimes it doesn't matter, but sometimes it does. Usually if I'm going to be picky about that, I will let you know on a quiz for sure. If I don't, then you should be able to do what you want, and if I mark you wrong, you can call me on it. Okay, so we're going to go ahead and just cross multiply and figure out that that comes out to be approximately 23.4 ounces is needed for the 14-inch pizza. Okay, so that's our answer for that one. On page 14, you have some reminders of the volume formulas for rectangle over box, or for a cylinder, which we just kind of used ahead of time, where they were talking about, I'll just back up here. This problem, your book, I think, does as an area, but like I discussed, this really is assuming the thickness or height is 1. So I used volume for that one too, because I think it makes more sense. The problem here, example 1.14, I actually want you to do as a classwork. And see if you can set that up. Set up your proportion. I'm going to just give you a few hints here. If you want to pause now before I give you the hints, go ahead and do that. Okay, we have a website says that 48 50-pound bags of sand are needed to fill a sandbox that measures 8 feet by 8 feet by 1 foot. So we have the height there. How many bags are needed for a sandbox that measures 6 by 4 by 1, all in feet? So again, the clue is here, we need to compare the volumes. We can't just take the individual measures. So you want to set up the bags number of bags over your volume in, it'll be cubic feet. Okay, so that's how your proportion is going to set up. So go ahead and try that, and I'll write out the answer as well, and you can check back. You should get 18 bags is what the answer is. Okay, so here I've set up the proportion, 48 bags over 64 feet, cubic feet, equal to X bags over 24 cubic feet, declaring my unknown. It's the number of bags for the smaller sandbox. Did my math, cross multiplying, get 18 bags. So 18 bags are needed. I'll write that in there a little bit better. So hopefully you're getting the idea with this that you have to incorporate more than just one of the dimensions and take them all into consideration when you're doing your proportion setup. So that's it for this segment, and the next one will be on page 15. We'll continue on with some estimating and doing some larger scale word problems. So thanks for watching. Have a great day.